then start. Okay, so welcome everyone in the fourth session of ISTQB Certified Tester Foundation Level Training. And I hope that the last three sessions were useful and you have got all the knowledge which we discussed in the three sessions. And I hope everything is clear. So just let's do a recap. In last session, we covered test process, and as part of the test process, we covered that what is the impact of context on the test. Also, we discussed different kind of test activities and what tasks there are in a test process. Then we also looked at different outputs or work products that support the test process. And also we learned the value of traceability and why it is important to maintain the traceability between the test bases and the test work products. So today, finally, we will finish our first module, Fundamentals of Testing, by covering this last part, the psychology of testing. We will also begin the second module, which is testing throughout the software development lifecycle, and we will do a portion of the first section, which is software development lifecycle models. Okay, so let's start with the psychology of testing. Okay, so for any project, the mindset of a tester is different than that of a person who has developed, like developer, or who has written the requirements, like business analyst. So intention of the entire team is to complete the project according to the customer requirements. But in order to do so, a tester's job is to look out for defects. So to understand the psychology of testing a bit more, let's first go through this term confirmation bias. So what is confirmation bias? So I can give you an example for that. Let's take this training as an example. So I am the instructor for this training. My aim is to deliver this training in the best way possible so that all of you can pass the exam. Now, just imagine that someone external, they audit my training and they spot few issues or maybe few gaps, and they generate a report and let me know that, okay, there were a few gaps in your training or you didn't cover it correctly, etc. So I delivered this training with good intention and I put all of my efforts. So it will be difficult for me to accept that the training I am providing is not good. So this element of human psychology is known as confirmation bias. When we talk about projects, then the devs think in a similar way that there are no errors in their code, and business analysts think that there are no gaps in their requirements. So now tester is someone who is doing their job, but actually they are breaking the bad news by highlighting defects. So some people see testing as a destructive activity because it's a human trait that anyone who is bringing the bad news is blamed. And in this case, it's tester. So what a tester needs to do in this case is a tester needs to communicate defects in a constructive way so that the other members of the team can see the bigger picture of how the findings of a tester contribute to project's quality and can see that defects are raised against the software and not the developer or the business analyst, etc. So I hope that this term confirmation bias is clear. Okay, so now we just learned that the tester need to communicate in a constructive way. So now we'll go through a few ways of how to communicate in a better way. So first of all, start with communication rather than battles. So if a tester has reported a bug then the tester should not go into direct arguments, but should communicate it in a very subtle and polite way, not blaming the developer, but maybe that there is a defect in the software rather than criticizing the developer himself. So this is one good way of communicating the bugs. And secondly, emphasizing the benefits of testing. So whenever there is a doubt of that why testing is important. So a tester job is not only to look for defects, the tester is also the advocate of quality as well in the team. So at numerous times, they have to emphasize that why what they are doing is important and what will be the benefit of the testing they are performing. Because unfortunately, quality is something which is not visible. If a developer is developing something, let's say a web application, everyone can see that application form. But as we also learn in one of the principles of testing, that testing quality is something which we can't see, and we can't tell that whether the software which is delivered is correct or not. We also get to know about the quality only if when we test it. So that's why testing is very important, and that's what we need to communicate to everyone in the team, showing them a bigger picture that how testing will impact on the quality of the deliverable. Then communicate test results in a neutral, fact-focused way. So over here, again, not criticizing anyone, but just keeping your findings in front of whoever is the creator of that defect, or whoever has created that piece of code where you have found a bug. That okay, now you are going through these steps and you found this behavior which is not as per the requirements. So it's more of a like a start as more of a like a discussion, and hopefully that will go well. The fourth one is understand how other person feels. So as we just learned about confirmation bias, it's not only the developer, it's human nature that it's difficult to accept your own mistakes. So when we are reporting bugs, we need to be conscious of this thing, that when we are communicating to someone, how polite we should be, and how we should communicate the bug in a way that it showed that we are reporting the bug in the software rather than emphasizing more about that this developer hasn't done a good job. Then the fifth one, confirm that the other person has understood what was said and vice versa. So of course, when we are reporting bugs, we need to, yes, we are reporting it in terms of a quality management system, or maybe we are just reporting it via email or spreadsheets, etc., whatever the mode is in your company. But we need to further discuss it with the developers as well, because maybe the developer will come back to you that, oh, I'm not able to reproduce this, or can you help me with that, or what's the problem with that, I don't understand the bug you have raised. So so the discussion with the developer is very important, and we need to make sure that we are understanding developers, whatever the developer is saying, and developer is understanding what we are saying. So it's like a two-way communication, because maybe we have reported a bug, and after discussion, maybe we accept that, or maybe it was an invalid bug, or maybe yes, what the system was doing was correct, and maybe I interpreted it incorrectly. So these are all different ways of communicating in a better way. Right. Secondly, it's testers and developers mindset. So first of all, let's see what is a mindset. So mindset is a belief based on which we handle situations in our daily life. Now, developers and testers, they both are part of the same team, but their perspective, their objective is totally different. So a developer, when let's say that there is a new software which needs to be built, developer is straight away thinking that how can I build the application? And the tester will be thinking, how can I break the application? Now over here, if we see this term, how can I break the application? It sounds very destructive, but actually what does this mean is that a tester is trying to think that what can go wrong, and they are putting themselves in user's place, because sometimes we do make a mistake and we only realize when we are reviewing it or someone else check it, and that's why testing is important. So let's go further with the developers and testers mindset. A developer mindset is about designing and building solution because that's what their job is. And with the right mindset, they can also test their code. So it's not that a developer can't test their code, and actually they do unit testing. So when they are writing different components, they do unit testing. And this is something which some companies are doing and some companies are not doing, but this is a good practice to do, because then later on a few bugs can be identified, because most of them were covered in the unit testing. So a developer can test their own code as well, but confirmation bias, again, it can make it difficult to find error in their own code. Now, if we see the tester's mindset, a tester needs to verify and validate the solution. Also, a tester should be having an attention to detail and also motivation for good and effective communication and relationship. So when a tester is working in a team, the way the tester communicates with the rest of the team and also the person like which are beyond their own team, like stakeholders, etc., it makes a big difference in how other people perceive their role. With all this, the mindset difference, that's why independent testers, they increase the defect detection effectiveness. And that's why independent testers are brought in, so that they can do their testing independently. Because a tester who is independent, who hasn't played any role in the writing of requirements or in coding, they are seeing the application or the software which is being developed from a different perspective, and there are chances that more chances that they can highlight some defects which maybe were not identified earlier, either during requirement analysis phase or in the design and development phase. Right. Okay, so the next one. So now we are done with the first module, fundamentals of testing. And before we start the second module, if there are any questions, we can take those and then we can continue with the second module. Okay, so there are no questions, so I think we can begin the second module then. Right, thank you. Okay, so in the second module, it's about the SDLC models. So what we will learn in this module will be the relationship between the software development activities and test activities in the software development lifecycle. Also, we'll identify reasons why software development lifecycle models must be adapted to the context of project and product characteristics. Recall characteristics of good testing that are applicable to any lifecycle model. Okay, so to start with, first we will see that what is a software development lifecycle, which is also known as SLDC. And these are the activities performed at each stage in software development and how they relate to one another logically and chronologically. So when we are building any kind of software, there are different stages. And in each stage, there are different activities which are performed. So at this level, we are talking about a model which is adopted by the entire team. So over here, we are not specifically talking about testing. It's about any project that this specific project is being done using a specific SDLC model. Now, each SDLC model requires different test approach. So we can't say that if we have worked in a specific test approach, then that will be applicable to any kind of model. No, each model is different. There is a different reason why that model was chosen to complete a project. And based on that, a tester needs to define their test approach. And that's why it's very important that a tester should be familiar with all the common SDLC models so that they can plan their appropriate test activities. As we will go through the different models, we will learn that the way we test and the activities which are performed as part of each SDLC model are different. But one thing is common, that there are few characteristics of good testing for any SDLC model. So if you take any model, there are few things which should be there as part of good testing practice. And these are those. So let's go through them. For every development activity, there is a corresponding test activity as well. So whatever the model is, whenever there is a development activity, there should be a test activity against that as well. Each test level has test objectives to that level. So in last session, we went through the high level test level. So like component testing, integration testing, system testing, etc. So these are all test levels. And for each test levels, we will have different test objectives. Next is test analysis and design for a given test level begin during the corresponding development activity. Okay, so as we, the first point, it was that for each development activity, there is a corresponding test activity, right? Okay, so over here, then for each that development activity, we will start the test analysis and design for a given test level whenever that development activity is being performed. The next is testers participate in discussion to define and refine requirements and design and are involved in reviewing work products as soon as drafts are available. Okay, so it depends what kind of model is being used for that project. So for example, if it's done in Agile, then there is a refinement, the backlog refinement session, and mostly testers are part of that session because they are also contributing, they are also giving their input. So they are part of that activity in Agile model. Similarly, in other models as well, there are different different stages where the testers, they do participate when the requirements are defined or refined. Right, okay, so now the SDLC models, there are lots of different models, but as part of this syllabus, we will cover few of them. And these are mostly, and these will cover like mostly all the common models which we are right now using in the market. So the main ones which we will do is sequential, incremental, and iterative. Okay, let's start with the sequential model. So a sequential model is a linear model in which all the activities, they are followed sequentially. So means that if there is a specific phase of the development process, the next phase can't be started until the previous phase is completed. So in theory, there is no overlap in the process. No overlap means that first phase needs to be finished before the second phase can start. So this is in theory, but in practice, it is beneficial to have early feedback from the following phase. So usually in theory, there is no a lot of feedback, but when we are doing it practically, it's always a good practice that we get some early feedback as soon as possible. The third point of this model is test activities only occur after all development activities have been completed. Okay, so we will see it in the next slide. So under sequential model, there are two models which are quite well known, Waterfall model and V model. So these are two types of sequential models which are usually used for different kind of projects. So when we are using sequential model, it's like when it delivers software that contain the complete set of features, but typically require months or years for delivery to stakeholders and users. So let's say if there is a project which is 6 months long or a year long, and the requirements are defined and they are stable, and there is no chance of those requirements to be changed, then one of these model, waterfall model or V model, would be a good model to do that kind of projects. And this is also known as a traditional model as well, because earlier, before Agile, these were the two most famous models which were being used. And even now also, there are a few scenarios in which these models are used purposely. Right. Okay, let's see what's a waterfall model. Okay, so in waterfall model, as the name says, waterfall. So everything, every step goes sequentially. So the first step is requirements. So in requirements, the requirements are analyzed. Then comes the design. So once the requirements are analyzed, we finalize the requirements, everyone accepts the requirements, only then the design phase begins, which means that now the design phase has begun, so we are not going back to the requirements. So we are just going sequentially to the next step. So in design, then we design the test cases. For example, this is one of the activity. So then it comes the implementation phase, and we build the software over here. And then comes the testing. So we are done with requirements, design, implementation. We got the build for testing, and now we are performing testing over here. And once testing is signed off, then it will be released and the maintenance phase can begin. Right, so this is what a waterfall model is. Okay, so can someone tell me that what's the disadvantage of this model? Can someone guess that? Maybe you have already worked using waterfall model, or what do you think by the look of this flow? What can be the disadvantage of this model? Cannot change the requirements at later stage, Sahana. Yes, Sahana, that's absolutely correct. Right, okay, so let's say that we are here in the testing phase, and we have spotted few errors, and the errors are fed back to the requirements. Then we spotted out there are few changes required in the requirements, but then it will be too expensive to make the changes, because we did learn earlier that the later we found the defects, the expensive it is to fix that. Let's see what other people are saying. So Himanshi is saying we cannot apply in long project. So Himanshi, we can apply to the long projects, because usually waterfall is adapted when we have long projects, but there should be another thing in conjunction, which is, as I said, that the requirements need to be stable. If the requirements are stable and there are no changes in that, then yes, we can apply to a long project. I can give you an example for that. So let's say this 2018 syllabus for the training which we are doing for ISTQB. Now, this training this will be completed in, let's say, 2-3 months. It will take 2-3 months to complete, and we already have a defined syllabus for that. So there is so now this is a good candidate for waterfall model, because we are not expecting any changes in the syllabus. Because just imagine that we are in the middle of the training and then we came to know, oh, the syllabus has changed. Yes, sometimes of course syllabus are updated, but it's not like that every month or every 2-3 months the syllabus is changing. It's not updated that frequently. So that's why waterfall can be applied to the long projects, but only when the requirements are expected not to change. I hope that's clear. Okay, Mira. Parallel testing is not possible. That's correct. We have to wait for all the stages like requirements, design, implementation to complete before we can even begin testing. Right. Himanshi, you're also saying phases are processed and completed one at a time. Yes, yeah, that's right. Vineet, once an application is in the testing stage, it is very difficult to go back and change something. Absolutely correct, Vineet, you are right. So it's very difficult. Okay, so so now we have gone through the disadvantage. But let's say that we are doing this a project in waterfall model, and there can be some benefit to this model as well, and that's why this model is still in some places it's being used. So can you think of a pro for this one, for this model? What can be the advantage of this model? So we already said that, yes, for long projects, it can be a good candidate where the requirements are stable. So can you think of any advantage? Okay, Jatan is saying each phase has specific deliverables. Which is true that we are having specific deliverables, but maybe just think of like a bigger picture, and we'll come to that point later. Easy to arrange tasks. So this is what Himanshi is saying. Anthony is saying simple and easy to understand and use. Vineet is saying each phase has specific deliverables and a review process. Okay, so first of all, this is a very simple and easy to use model because everything is structured in a proper way. So one phase begin, it ends, and then the new phase starts. So first of all, it's a very simple one to understand and to follow. And the second benefit of this model is that it's not very expensive. So now this term, this sentence which I'm saying can be very controversial, because this can be an advantage or a disadvantage. It can be disadvantage, as we just discussed, that yes, if later on we come up with any changes in the requirements, it will be very, very expensive. But in the other case, as we said, that if the requirements are very stable, then it can be less expensive to use this model. And the reason is that in this case, we don't need anyone from testing until the requirements are done, design and implementation is completed. So maybe if there is a test resource, we can involve a testing team or a test resource only for that specific period of testing, let's say 1 week or 2 weeks, rather than for the entire project. So of course we are cutting the cost, and it's not only for testing, the same goes for the developers as well. So developers have the requirements, stable requirements, detailed requirements in written form, so they don't need to be involved in the requirements analysis in the beginning. In the traditional model. So that's why it can be very less expensive as well, depending on if it's the right model to be used for a specific project. So we have a few more comments. Let's see. So Himanshi is saying works well for smaller projects where requirements are very well understood. Yes, so again, I wouldn't say that it is a good candidate for smaller projects or bigger projects, but yes, it it can work for both. But yes, if the requirements are very well understood and defined, and there are no chances of the requirements being changed, then yes, it could be a good model to be used. Vineet is saying works well for smaller projects where requirements are very well understood. Okay, so yeah, is almost the same what Himanshi said. Okay, so Mira is saying if requirements are analyzed and understood, the question will be cleared for requirements. So there won't be any changes in test design at all. Yeah, so if the requirements are well defined and a lot of effort has been put in it and everyone has signed off on the requirements, then yes, there are less chances that there will be any changes later on. Pallavi is saying stages are defined very clearly. Yep, that's correct. So yeah, so seems like that everyone is clear with the concept of waterfall model. Right, good. So let's go to the next one. And the next one is V model. So now V model, as the name says, it's in a V shape, as we can see in the image. So V model is basically known as verification and validation model. So we earlier, I think in the session, in the first session, we went through the terms verification and validation. And over here, what are we doing is that for each phase, there is for each verification phase, we have an equivalent validation phase as well. And implementation, which is the coding bit, this is the part where they are being joined. So we start with requirement analysis, then there is high level design, then detailed design, then we have implementation. After implementation, then unit testing is done against the design phase. Then integration testing is done against the high level design, and system testing is done against the requirement analysis against the requirements, because that's what we do when we are testing against the requirements, and that's what we call system testing or functional testing. Right, okay, so now there are few cases where though V model is a sequential model, but sometimes we do mix different models as well to come up with a hybrid model, which works in a better way for our project, depending on what kind of project we are working on. So over here, again, the requirements are well defined, they are stable, and mostly this is used for like small projects, and this is very simple to understand and use. And the good thing is that for each phase we have an equivalent testing activity as well. Now again, the difference, the disadvantage over here again would be the requirements change. That if you see that we are going through the entire V, and the end of the V, we are where the V is ending, we are doing our system testing over there. Though there are parallel activities for each phase, but the test execution, we are doing it at the end. So if there are any changes spotted at that level, again, we'll come across the same disadvantage as we had in the waterfall. Yeah, though we can say V model is an extension of waterfall, but still there are some cons which were in waterfall which exist in V model as well. And the change in requirements, how to handle change requirements, this is one of that. And again, then no working software will be there until late during the life cycle. So we are not, as we will learn in the further models which are incremental and iterative, so still we have to complete the entire life cycle before we can deliver something, before we can show something to the end user or the stakeholder. Right, okay, so now I hope the V model is also clear. If there are any questions, let me know. Otherwise, we will move further. Okay, Sujan is asking, what is the system testing that is done during requirement analysis? Okay, Sujan, so now over here, let's not confuse ourselves that we are doing any testing during requirement analysis. No, 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 we are not doing any testing during requirement analysis. What we are doing is that for requirement analysis, we are designing our test cases. So over here, yes, we have the requirement analysis, but at that time we can't test anything because we don't have anything built at that stage. If we go through sequentially through this V model, the shape of V, the steps are done in this sequential way, in a flow. So we can't start system testing until we have a product which is built. But yes, how it is associated to requirement analysis is that yes, in a V model, let's say if there is a requirement analysis phase going on, at that point, if the tester is also being involved, then the tester can write can do some review activities. They can't do system testing at that time, but they can do some review activities if they are involved. Or this two-way communication which is being shown is because the system testing is done against the requirements. That when we are testing something, we have a set of requirements which we are comparing the actual product against. So I hope this is clear. Right. Okay. So let's move on to the next one, which is incremental model. Okay. So now in incremental model, there are few important points which we need to remember. The first one is it involves establishing requirements, designing, building, and testing a system in pieces, which means that the software's features grow incrementally. So we will go through an example later on so that you can understand all these points in a better way. The second point is the size of these feature increments varies, with some methods having larger pieces and some smaller pieces. The third one is the feature increments can be as small as a single change to a user interface screen or new query option. So to understand these points, let's go through an example and then we can come back to this one again. Okay, so let's say that we have our requirements in which we have to build an e-commerce application. So in an e-commerce application, there can be different features. So we are just discussing three features for this example. So let's say that we have a component which is products, where all the products can be seen on that website. Then the second one is add to cart. And then the third one is checkout. So for this example, we are just going through these three features. So now the requirements phase, in the requirements, we in incremental, we still have the full-fledged requirements in place, but the way we are building the product is that we are dividing those requirements into different phases, different increments. So what we are saying that we will take, let's say we are dividing the requirements into three phases over here. So we will work on the product section first. So we'll take the product feature, we will design it, develop it, test it, and implement it. And then we will show it to the stakeholder. And then when it's done, then we will go back and we will take the second feature, which is add to cart. So let's say in the first phase, we have the user can see all the products, but the website is not functional apart from this thing that they can view different products. Then the second phase, what they have done is that now the user can add the products to the cart. They can choose the products and they can add to their basket. So now for this one as well, it will go through the same cycle. So this will be the second increment, same cycle, design and development, testing, implementation. When this is done, then the third phase, which is checkout, this feature will be taken and the same activities will be performed. So what we are doing is that we still have the full-fledged requirements over here, but we are building it incrementally. So another example in our day-to-day life, which we can take is an example of building a house. So let's say that if we take the incremental model, then we are building one room, we are painting it, we are furnishing it, and then only we are moving to the second room. Then we will build the second room, and we will then furnish it, we will paint it, we'll do all the decoration, and then we will move to the third room. So we will complete one phase, and then we will move to the second one or third one. So this is known as incremental. Then we have iterative. So iterative is that we are still doing different activities, but they are doing iteratively. So we have different iterations, and this is what we usually use the agile for. Actually, agile, if we do in a proper way, it's a combination of iterative and incremental. So we will go through that as well. So over here, what we are doing that, yeah, we are still going through the same phases, like we are analyzing, designing, implementing, testing. But what is happening that over here, the second iteration have some inputs from the earlier iteration. So it's not that it's totally isolated from the earlier one. In the incremental, we will just we were like completing one feature, and then we were moving to the second one. Over here now we have like few requirements, and it can be that the requirements are not very mature at this point. Maybe we have just maybe the client just come and say, oh, I want an e-commerce website, but I'm not very sure. So can you start working on it? Show me the prototype, and then we can see that how we go from there. So maybe in the first iteration, the team can just build up a prototype, a very rough sketch, and then the user can say that, oh yes, yeah, I think this needs to be changed. I want it this way. Then slowly, then based on that prototype, they will start building something. With each iteration, they will be it will be shown to the stakeholder, and then based on their inputs, they can make the changes. So for any good project, incremental and iterative, mostly they are combined, because it has a very a good combination of both of them. And if we use any project where we combine incremental and iterative model, then we can really achieve good results from that. So few of the examples which we will go through today is the type of the processes or the methodologies which we are using following these models. So one is RUP, which is Rational Unified Process. So over here, each iteration tends to be relatively long, for example, 2 to 3 months, and the feature increments are correspondingly large, such as 2 or 3 groups of related features. So if you can see, I have highlighted that in this process we are using both iterative and incremental model. So there are so many processes which we can use for doing a project, and it doesn't have to be like one of them. Again, when we analyze the requirements, when we go through the objectives, what's the goal of our project, then we can decide in one of these models that which methodology we want to use. The second is Scrum. So Scrum and Kanban, they both are part of Agile methodology. So in Scrum, each iteration tends to be relatively short, for example, hours, days, or a few weeks. And the feature increments are correspondingly small, such as a few enhancements or 2 or 3 new features. In Kanban, it's implemented with or without fixed length iterations, which can deliver either a single enhancement or feature upon completion, or can group features together to release at once. So now Scrum and Kanban both are part of Agile methodology. So the only difference is in Scrum we have fixed windows that, yes, a Scrum is for 2 weeks or 3 weeks, and in these 2-3 weeks we have to deliver this functionality. And these can be different features as well. So it's not that one feature will be completed and then we will deliver this. It's like a time boxed in terms of how long an iteration would be. In Kanban is that like when, yeah, we are doing it in agile way, but we have a feature which we have to finish, and we don't have any specific timeline for that. So we don't want to time box it like we want to finish it in 2 weeks. No, like if we just want to finish that feature, and then we just want to keep on tracking that we are doing it in a proper way, so we can use Kanban in that way. Okay, Spiral. So in Spiral, it involves creating experimental increments, some of which may be heavily reworked or even abandoned in I think it's a typo over here, subsequent development work. Okay, now Spiral, if we see the way the Spiral model works, we can also say that it's a combination of incremental and also sequential as well, because it is a waterfall model, but it also have a very high emphasis on the risk analysis as well. And then everything is delivered incrementally. So we can say that yes, it's a combination for both sequential and incremental. And that's what we do, that we have all these common SDLC models, and we can combine all these models in order to achieve the objective of the project which we are working on. And later on, when we will also discuss the other concepts, which are continuous integration, continuous delivery, and also the way we do regression testing, which keeps on piling up with each version, then we will, these are all different things to which we consider for that which model would be good. Right. Okay. If we have any questions, we can take those at this stage. Otherwise, we'll move forward. Right. Okay. So I think there are no more questions. So I hope that these models which we discussed today, they were clear. And now when you will come across any specific model, you should be able to identify that, yes, which model it is. Right. Okay. So this will be the end of today's session, and we will continue with the SDLC models, the next topic. Under this, I think the next topic would be, let's see, the next topic, no, I think we are not done with SDLC models yet. We will continue doing it in more detail in the next session, which is on Thursday. So let's go through the few practice questions. So I'll go through the question. I'll give you some time, take your time, and then let me know that which one is the correct answer. So the first one is, which one of the following is the best definition of an incremental development model? Take your time, go through the options, and let me know that which one is the correct. Okay, so we have got an answer. So let's see, someone else who wants to attempt. Okay, so Himanshi, you have said it's A, which is absolutely correct. Anthony, you are correct as well. It is A. Jatin saying A, Sahana A, Umair A, Madhuri A. Perfect. Everyone is saying it Right. Okay. So which means it is clear. So A is incremental. Let's see the other options as well. So the B is a phase in the development process should begin when the previous phase is complete, which means that this one is sequential. Then the third is testing is viewed as a separate phase which takes place after development has been completed. So a separate phase, that would be waterfall, that yes, it's testing is a separate phase and it's done when the development is finished. And so it will be waterfall. The last one is testing is added to development as an increment. No, it doesn't happen at all. It's not an increment. Testing is never done as an increment to any feature. It's part of that model. Right. Okay. And the second question is, which of the following qualities is more likely to be found in a tester's mindset rather than a developer's? So carefully go through the options and then let me know what do you think is the right answer. Okay, Mira is saying it's B and Sahana is saying D. Okay, so we have different opinions for this. Let's go through that. Let's just see what other people are saying. Vineet is saying A. Okay, that's interesting that we have like quite a different opinion on this one. Madhuri is saying B. Umair is saying C. Pallavi is saying all of them, right? Okay, Himanshi is saying A. Anthony D. Okay. So the correct answer is B, ability to see what might go wrong. Okay, so you will come across in the exam, you will come across these kind of questions where there is a keyword in the question. Like for example, I have written it in caps, which is more. So sometimes this keyword, it plays such a vital role, the way the question is asked, and with this keyword it just changed the entire question, and then it plays a role in how we are answering it. Okay, so in first instance, yes, B is, I know B is the right answer, but D is also a good candidate for this because we did mention in the tester's mindset, if we just go through the slides, in the first one, maybe over here, in the tester's mindset, we did read that it says that a tester should be having an attention to detail. So yes, D can be a good candidate, but the problem over here is that if we go through the question again, which of the following qualities is more likely to be found in a tester's mindset rather than in a developer's? So yes, we did learn that a tester should be having an attention to detail, but it didn't say anywhere that a developer shouldn't be having an attention to detail, because a developer who is developing the product based on the requirements, it's required that they can also pay attention to the details. So it's equally important for a developer's job as well to pay attention on this aspect. So this trait is not more likely to be in a tester. It can be in a developer as well. Actually, we need it in a developer as well, and for everyone who's working on that project. But yes, why B is the correct answer? Because a tester should be having an ability to see what might go wrong. And why is that? Because a tester's role is to see the application from the eyes of a user, of an end user, and then saying that, okay, what can go wrong? So it's just equivalent to when you think of that you are user of any application, and what things can frustrate you, what things you think that can go wrong. So a tester thinks more in that way. Right. Okay. Some people also said it's A. A tester's mindset tends to grow and mature as the tester gains experience. It's true for the tester, but then the same is true for a developer as well. A developer, when they start scripting, yes, they learn, and by the time, through the time, and then yes, after a few years of development experience, they also get mature in the way they are working. They also gain experience. So we can't say that this trait is more likely to be there only for a tester. And C, good communication with team members. Yes, we said that the communication plays a vital role. The way testing is being perceived for that project, but it doesn't mean that the other team members, they don't have to communicate in a good way. They needs to be good in communication as well for different reasons. And of course, at the end, everyone is in the same team. They are working together, and everyone's communication skills should be good. They need to communicate and treat each other in a nice way. So B would be the correct answer. I hope that everyone is clear on this one. Okay, Sujan is saying, I still have doubt why B is the answer, as developers also consider what might go wrong, and also they do unit testing as well to ensure the product is built in a right way. Sujan, this is a very good observation, and let's see that why B is the right answer. Okay, so to answer your question, I will take you back where we went through the mindsets of developer and tester. Okay, so we read over here that with right mindset, they can test their own code. Yes, you are absolutely right that they do unit testing. It's part of their job that they are doing unit testing. But when they are doing unit testing, they are not always covering the all edge cases as well, or all scenarios. It's the tester who usually come up with, okay, what can go wrong? Okay, this is first, when we test all the positive scenarios, that okay, it's doing what it should be doing. But then we also start thinking that, okay, let's see what happens if I do this, and which is not part of the requirements, but we go beyond the requirements, and we start doing some negative testing as well. Developers usually don't do that kind of testing. They are more concerned of building the solution, and yes, they do want to build it in the right way, but it's very rare that they will think of that why something has gone wrong. And then secondly, because they have written their own code, we also studied about the confirmation bias, that this is also something which makes it difficult to find errors in their own code. Okay, and some places code reviews are done in the development activity, but in that what happens, that a developer who has developed a part of code, they don't test their own code. Another developer tests their code, they review their code. This is known as code review. So that can be a very good practice as well, because let's say if I have built something, and even if I'm going through it again and again, because now I have a specific mindset, or I have seen it so many times, that we need some fresh pair of eyes, a different perspective to understand it better. So either so sometimes any kind of issues can be pointed out in unit testing. So unit testing, at least we can ensure that if unit testing is done, then all the positive scenarios should be working. Yes, then we can concentrate more about the negative scenarios. When a developer do a code review of another developer, at that time what mostly they are seeing is that yes, it's implemented in a good way, and also it's not impacting any other areas, any other components of the system later on, which will be integrated. So I hope that this is clear, that why B is the correct answer. Okay, Mira is saying developers do testing with a mindset that so and so functionality is a working positive path. That's absolutely correct, Mira. Okay, so Sujan, yeah, okay, great. Thanks for the explanation. You are most welcome, Sujan. So I'm glad that it's clear now. Right. Is there any other question? Okay, so what I will do that after this session, I will share the recording. I will also share the slides, and tomorrow morning I will upload the questions as well. So now, as we agreed to have 2 sessions per week, it might be difficult for you to catch up and do the questions because you will not get the entire week. You will get actually only 1 or 2 days. So I will strongly recommend that please do the assignments as soon as you can, because let's not just pile up everything and say that, yes, I can do this maybe 2 or 3 assignments together, because then it will be difficult for you. Like, for example, now you have gone through this session today, it's still fresh in your mind. It will be easier for you to do the questions related to this session. And also, if you have any question, then you can ask us as well in the group, because still it will be fresh in your mind. So it will be, I will recommend that, yes, if you will do it as soon as you can, that will be good. Right, I think we have one more question. Which model is used mostly? Okay, so Umair is asking this question. So Umair, it depends. Nowadays, mostly it's agile. And in agile, we can do Kanban or we can do Scrum, but Scrum is more famous. There are a few specific reasons why some teams use Kanban. Like, for example, I have worked in many places where in the same office we are using different models for different projects. But if you ask which model is mostly used, is Agile, and in Agile it's Scrum. And the reasons are very, very clear, that it allows the changes to be reviewed and accommodated very easily, frequently, and we can deliver after maybe few hours, every few hours as well. We can deliver something with the continuous deployment. So this is what is being mostly used nowadays. Right, okay, so what else do we have? Vineet is also asking which is trending model. Yes, again, it's Agile. Agile with the combination of Scrum. And yes, the Scrum, the way the sprints are done, they do vary. Some teams, 2 weeks is the most famous window which is being used, but some places they are also doing 3-week sprint or a 1-week sprint as well. The 2-week sprint is more common. Right. Okay, so then we don't have any more questions, so we can end the session. Before we end the session, there's one more thing which I wanted to let you know. As we have now finished our first module, if you go through the syllabus of ISTQB Foundation, for each module, there are some keywords which we have gone through in that module, but you need to make sure that you know the definitions of those keywords, because those keywords will be asked in the exam again and again, or will be used in the exam, and we have covered all of them, so you shouldn't be having any issue. But just to keep the definitions in one place of that keywords, I have come up with a Word document with all the keywords and also its definitions. So I will upload that as well in the file section. So after the session, you can go through and just like make sure that you understand all the keywords definition, and the definition I have taken from ISTQB glossary. So if you go online and if you see the glossary of ISTQB, it has all the terms, but yes, all the terms are not necessarily for the foundation one, because of course there are other levels as well, like expert level, advanced. So they have a glossary in which you can find the definition for all the terms, but I thought it will be easier if we do it module based. So I have created a Word document which I will upload after this session. Right, just double check if there is any other question. Okay, so Umair is asking, what if anyone want to learn Agile, any source? So Umair, I can definitely recommend a few websites, tutorials, so which you can go through Agile. Or I would suggest that right now, as you are aiming to go through this ISTQB exam. So let's first concentrate on this one and finish your exam. And once you are passed with exam, then of course we can go through some agile training as well. I do have a plan which I will discuss it in the group as well, but as you are here, so I can communicate right now as well. So I was thinking that once we are done with this training and you have taken the exam and hopefully pass the exam as well, then we can start another training in which we can take a real-time project, and then we will apply all things which we learned. So now it's like theory, we are going through all the concepts, all the keywords, and then we can take like a live project and we can go through that, and maybe that project we can do with agile model, so we can do that. So this is something which I will communicate in the group as well, because if you can see, we have like a lot of members in the group, but I don't think everyone is being that proactive in the group. I'm not sure whether it's because it's a free training and maybe it's taken for granted, but I'm really thankful to all of you who are making an effort of attending the sessions. And for some reason, if you're not able to attend, then you are taking the effort to do the assignments and trying to learn. And everyone who do all the assignments with me and also do the mock exams, then I'm happy to offer them a completion of training certificate. And also later on, only those candidates will be continuing with me on the live project, because usually this live project training, I do a paid training, but for everyone who has shown the commitment throughout this course, that will be free for those. So I hope that will motivate everyone to be committed to this and pass this exam. And then later on, there are many other things which we have planned for someone who really wants to learn. So yes, we will do agile as well. All right. I hope that helps. And with that, then we can end this session. So take care of yourself, and I'll see you on Thursday then. Okay, bye.